In this short video, we will try and understand the Lagrange multiplier test for small q exclusion restrictions. It means suppose we have 5 variables in a regression model and we want to test whether 3 of the variables are jointly statistically significant or not. Then we can use the Lagrange multiplier test. So the steps involved in the Lagrange multiplier test are as follows. So first step is to regress the y variable, the dependent variable, on restricted set of independent variables. So you have the restrictions imposed with respect to beta 3, beta 4 and beta 5. So you are left with only variables x1 and x2. So regress y on x1 and x2, x1 and x2. Okay, and then obtain the residual from this regression. And then in the second step, run the regression of these residuals u tilde on all the explanatory variables, that is x1, x2, so on up to x5. Then this regression is termed as the auxiliary regression. Okay, then in the third step, compute lm is equal to n into ru square. The r squared that you have obtained from the step 2 should be multiplied with the sample size, and then this test statistic is chi-square distributed with small q number of degrees of freedom. Small q is number of restrictions. In above case, small q is equal to 3. Okay, so you can finally test for whether this is statistically significant or not by checking the table or calculating the p-value. If lm is greater than c, then null hypothesis is rejected. Otherwise, we fail to reject the null hypothesis. Thank you. Okay students, let's compare the steps involved while conducting Lagrange multiplier test versus f-test. Okay, suppose we have 5 variables out of which we want to test a joint hypothesis of whether 3 variables x3, x4 and x5 they are jointly statistically significant or not. Lagrange multiplier steps I have explained in last video. On the right hand side, I have written the steps involved for calculating the f statistic and conducting this f test. So first of all, you have to regress y on restricted set of independent variables. Restricted means which we don't want to jointly test, that is x1 and x2. We want to test x3, x4, x5 to be 0. So we have to run this regression, restricted regression, on only x1 and x2 and save the SSR, that is sum of squared residuals, for this restricted model as well as the r squared from this restricted model, and name these as SSR. You can write it as SSR and r square r. Okay, in the second step, regress y on all the variables, that is unrestricted model. Regress y on x1, x2, so on up to x5, and then save the sum of squares residuals, that is the unrestricted model, as well as the r squared for this unrestricted model, that is r squared ur. Okay. In the third step, calculate the f test as f is equal to SSR of restricted minus SSR of unrestricted divided by small q, and the whole thing is divided by SSR unrestricted and this denominator divided by n minus k minus 1. These are the degrees of freedom. Okay, and then you can calculate the f test with the help of SSR as well as the r square from the restricted and unrestricted models. Okay, once you calculate the f test, so this is distributed with these many degrees of freedom. Small q numerator degrees of freedom and n minus k minus 1 the denominator degrees of freedom. And then you calculate this calculated test statistic with the critical value. If it is higher than the critical value, then we reject the null hypothesis, or otherwise if it is lesser than the critical value, then we say that null hypothesis, we fail to reject the null hypothesis. Thank you.